The next one is verify. Now we are going to start with the DC panel. We finished the batteries are connected already, and right now we are going to start with the connection of the DC panel, and the selection and the sizing of the DC panel. Okay? The first step to calculate the DC panel that I need for my new boat is this. Verify where should be located the DC panel and avoid proximity with the AC panel. I have a lot of experience doing wirings like this. I don't like boats where the DC panel and the AC panel use the same compartment and both of them are together. I don't like that because soon or later you can make a mistake and you produce a short. Remember what is the most common mistake? The hotline, the black cable on the hotline on the AC panel is confused with the negative of the DC panel, and some technician mixed one cable with the other one and kaput. Try to avoid proximity in between the DC panel and the AC panel. Try to explain to other contractors. Try to explain to the customer, to the captain, that that location together in the same compartment is not recommended. Okay, if at the end of the day this is the only possibility, okay, but you need separate both of them with a special insulation material, bakelite or fiberglass, in order to avoid that some cables pass from one side to the other side. Be careful with that. I prefer, if it's possible, in a separate area. Okay. Make a list of all equipment that should be powered from the new DC panel. What is the meaning of that? You need to make a list of all the equipment that we are going to connect together on the DC panel. Okay, I am going to install 5 blowers, I am going to install lights, I am going to install all the DC equipment. You need to make a list, and in front of the list put the capacity of each equipment in amps per hour. Because according with that information, where is located that information? In the label of the equipment. The label says the voltage and the intensity, the consumption in amps per hour. With that consumption, you select the breaker for that equipment. Okay? That information, you need to make the list, make the table, similar to the table that you have on the screen right now. In that table, you have the name of the equipment and the consumption in amps per hour. And according with that, you select the breaker recommended for that equipment. This is a very important table, very important information. Because according with that, at the end of the day, like you have on the screen, you have how much is the total consumption of your boat. And how much should be the capacity of the main breaker for the new DC panel. With that information, you can select the type of panel. Try to select the panel that best suits your requirements. Always use marine approved vendors. What is the meaning of that? With the information that you have related with how many breakers I need and how much should be the capacity of each specific breaker and how much should be the capacity of the total main breaker, with that information you can select the panel in marine vendors. You can check the panel appropriated for the area, the space that you have in your boat. Okay, with that information is important because you can select the properly panel in dimensions, the properly panel in amount of breakers, and also there are panels with the voltmeter and ammeter and battery bank tester incorporated on the panel, like the panel that you have on the screen right now. Or there are panels that you need installed separated the gauge for voltmeter, ammeter, and battery bank tester. I prefer, if it's possible, select a new panel with those gauges incorporated. It's better. It's easy to do the wiring. And it's easy the installation and the troubleshoot of future problems. And you avoid less wires, long wires in between the gauge and the breakers. All right, select an approved marine vendor, because those vendors require all the specification of ABYC and other federal regulations. Okay, very important. And the next one is size the main DC feeder cable and the main breaker. Exactly, with that procedure you select the main breaker and the gauge of the wire in order to bring the DC power. This is the feeder, that's the power coming into the positive bus bar of the panel, that's the main power coming here. That cable is coming from the positive of from the switch selector, from the battery switch selector in the output. This cable is coming from the battery switch selector in the output, and you need to calculate the gauge of this wire according with the amount of breakers and according with the capacity of the breakers. This is the positive bus bar, this is the feeder for the positive bus bar, and those are the individual breakers. Okay, this is very important. In this particular case, this panel, the front of this panel is this. With the ammeter, the voltmeter, and the breakers, the individual breakers. In the back, it's exactly like this. This is the positive bus bar, and this is the output of the breakers. This is the voltmeter and ammeter. Voltmeter and ammeter. Right now, I am going to explain the procedure to connect each instrument and the procedure to do the troubleshoot on this panel. Okay, in this step, you need to calculate the gauge of this wire. The wire gauge is according with the total consumption in amps and the total distance in between the panel and the battery bank. All right? Okay, right now we are ready. We have the feeder, the main positive cable coming from the battery switch selector into the panel. We select the panel appropriated. We check different options with different vendors, and finally I take the decision. This is my panel, the panel that I am going to use, because in this panel I have in the future the possibility to add more breakers, and this panel have in the future the possibility to add more load. This is very important. Never buy a panel in the limit, because in the future normally the customers, the captain, they need install additional equipment. Okay. The next step is verify how many extra DC subpanels will be working from the main DC panel. This is a very important information. Some boats, some manufacturers prefer install the main DC panel, and that panel should be the manager of the rest of the small DC panels. Let me explain that. Some manufacturers, they have one breaker in the main panel, and that breaker says electronics. When you activate that breaker, electronics, you send power to other small sub-panel, like the panel that you have on the screen, for electronics. Radar, GPS, transducer, all of those electronics equipment receive power from this main breaker electronics located in the main panel. This is good in order to take administration from one central point. Other people say, no, I prefer my electronics sub-panel independent, completely independent. All right, that's your decision. There are other boats that they have one breaker on the DC panel with the label crew, team crew. With that breaker, I activate the DC power for the crew in my boat. No, I don't like that. I prefer a separate sub-panel for that purpose over there. All right, that's your decision. All right, you need to investigate. You need to talk with the other engineers, other contractor, with the manager of the project, and ask to him, you want that in the main DC panel all the sub-panels be administrated, or you prefer those sub-panels independent? Okay, this is an important question, and this is important because if you introduce all of those sub-panels in the main panel, you need a bigger main DC panel with bigger capacity, and probably it's more expensive. And probably you don't have the space in the cabinet in order to insert that panel. That's other important consideration. Okay? And other important question, the next one. Check how many negative bus bars will be necessary and verify that all of them be connected together. This is very important. How many negative bus bars are in a typical boat? A lot. You found it in the console, one negative bus bar. You found it in the kitchen, other one. In the saloon, other one. In the engine room, other one. There are a lot of negative bus bars. You need to verify how many of those negative bus bars I am going to install, and verify that all of them should be connected together and connected with the main negative bus bar on the DC on the engine room. Alright? How many negative bus bars? Check the size of those negative bus bars. Check how big should be those negative bus bars, and how many cables I am going to install on those negative bus bars, and check if you have other small negative bus bars like this connected together with this, and this was connected with no, I don't have in this sub panel more, but normally in a typical boat you have like a 10 or 12 negative bus bar located in different areas. You need to verify that all of them be connected properly and connected together and connected with the main negative bus bar on the engine room. Remember that there are some equipments DC that they don't need a breaker. They don't need a breaker on the DC panel. Those equipments require power, constant power all the time. You remember? The bilge pumps. The bilge pumps should be powered all the time without any breaker. Why? Because you need that the bilge pumps works all the time. Doesn't matter if you turn off all the switches, you disconnect all the switches, those equipment, the bilge pump, they have power all the time. Those equipments like the bilge pumps should be connected from a constant positive bus bar. A constant positive bus bar like this. This is a constant positive bus bar coming directly from the battery bank. This is a constant positive bus bar. What is the function of this? I am going to connect the bilge pumps. The bilge pumps receive the power directly from this point. What other equipment should be connected here on the constant positive bus bar? The fire protection system. The fire protection system should be connected here on the constant positive bus bar. What other equipment you think that should be connected in the constant positive bus bar? Yes, the cameras, the CCTV, the security cameras, correct. What other equipment should be connected over there? Fire suppression system, bilge pumps, cameras, probably the VHF radio. The VHF radio is recommended. Connect with constant power. You have radio all the time. Doesn't matter if everything is off. This is important. And there are other equipments that depend of the manufacturer. They require constant power. For example, the router for internet. Okay, all right. This is the constant positive bus bar. You need to identify where should be located the constant positive bus bar and how much will be the overcurrent protection for that positive bus bar. This is a very important information. How much should be the fuse in order to protect that overcurrent, that positive constant bus bar? You need to install in between the positive of the battery and the positive constant bus bar one fuse for overcurrent protection. How much should be the capacity of that? You need to calculate that according with the consumption of the equipments connected in the positive bus bar. It's simple. Okay, the next one. Check the length and the gauge per each conductor according with the distance in between the DC panel, the battery bank, and the equipment. Calculate the gauge of the wires that I am going to use in order to connect blowers, lights, all the equipment. What gauge I am going to use? That gauge depends on the distance in between the battery bank, the panel, and the equipment. Once again, using the table from ABYC or using my formula. Remember, all of those gauges depend on the consumption in amps and the distance, the total length, and of course the voltage drop. Remember, the voltage drop is 3% for general purpose and 10% for lighting. That's mandatory. Okay, this is the most important information. The final is using a drawing tool for engineers. Try to make a professional wiring diagram following all the marine safety regulations and rules. This is very important. A professional wiring diagram. You need to give to the manager of the project and to the customer the wiring diagram in order to integrate that wiring diagram into the catalog of the boat. This is very important, and additionally you need to give to them a USB drive or a CD with the wiring diagram, and I recommend that you keep in your files in your office copy of those wiring diagrams. 100% sure in 10 years or 5 years or 20 years they will call to you asking for that diagram because they need repower the boat, rewire the boat, and they need that information. If you have that information, will be easy for the new contractor rewire the boat. Alright, this is the first step, and right now we are going to check some tips during the wiring on the board. Okay guys, right now we are going to start with some tips in order to do a successful connection of the DC panel. This video is not a complete procedure to wire the DC panel because I explained different process in a previous chapter. For example, I explained the procedure to connect the A.C.R. and the battery switch selector with the battery banks. You know that, and you have the pictures. For example, in this moment, you have on the screen the picture related with the connection of two battery banks with the switch selector and the A.C.R. This is the properly way to connect the A.C.R. In this moment, you have the A.C.R. For example, the picture on the screen is a boat with a single engine and only one alternator. And it's supposed that with only one alternator, we are going to charge both battery banks. The input of the alternator enter in the middle of the A.C.R., this A.C.R., and in each output, you connect the positive of each battery bank. In other words, with one alternator, I am going to keep charge both battery banks exactly the same at the same level of charge. Why? Because internally this element is composed by diodes and capacitors and try to keep the level of both charge equally. What happens when both battery banks are fully charged? This equipment absorbs the energy coming from the alternator and dissipate the energy through those fins of aluminum. For that reason, the majority of the A.C.Rs, they are fabricated with the fins of aluminum in order to dissipate the heat transfer. Alright, this is the procedure to connect an A.C.R. with one input and two outputs. And in the board that we have right now, we have an A.C.R. with double input and double output. And you have on the screen right now the picture to connect this A.C.R. Before we start, I recommend try to keep organized your tools. I recommend try to get a lot of cable terminals in different gauge, blue ones, yellow ones, and red ones. The most common numbers, terminals. The yellow one for gauge in between 10 and 12, the blue ones for gauge in between 14 and 16, and the red one for gauge 16 and up. Those are the most common terminal, the most common colors, and I recommend that you organize your terminals in a box similar to this one. And also try to buy the rolls of wires, professional marine grade wires in different colors, in different gauge, according with the calculation that you did before, according with my recommendation. And also prepare the battery cables. Prepare the battery cables properly crimped with a heat string using the tool that I recommend in the video that we are going to check right now. Now I am going to explain the procedure to install the battery terminal on the battery cable using the crimper, the box crimper. Alright, the procedure is, don't forget, try to buy this battery cable cutter. It's a special cutter for battery cables. With this one, you can cut the wire, and also you can cut it only the insulation. What is the procedure? I need to check how much is the distance of the plastic that I need to remove it. And I am going to remove exactly the same amount of plastic over there. Only cutting the plastic. With this tool, the same tool used to cut the cable is used to cut the plastic. And right now, my wire is ready, and I am ready to introduce the terminal. Before I introduce the terminal, it's recommended introduce the insulation, the heat string. I introduce the heat string, and right now I introduce my terminal. If you check the terminal, all the metal is covered. I don't have metal exposed like this. All the metal should be covered. If not, you remove the material. And right now, I have the crimper ready with the terminal over there. I am going to introduce the cable on the crimper. If you check, this is the crimper, and this is the terminal. I am going to introduce, and right now I am going to crimp it. And we are going to crimp it in other position over there. Okay, right now, if you check, the terminal is properly crimped, professionally. You can put on the vise and you can try to remove it. And after that, you slide the insulation, and with the heat gun, you apply the heat gun on the terminal. And right now the terminal is properly crimped. The terminal is properly installed. This cable is ready to be installed on the battery. Alright, I am going to prepare one cable. I am going to prepare one wire, and I am going to install one terminal quickly in one of these cables. Let me show to use the procedure to crimp it and install this. The procedure is like this. The first step is verify how much plastic, how much insulation I am going to remove according with the terminal. After that, you cut it, the insulation material, exactly the amount of material that you need to remove it. And right now we are ready to introduce the wire into the terminal and crimp it. In order to do that procedure, we are going to use the crimper tool. We are going to introduce the wire on the crimper tool, and now we are going to crimp it properly. After that, we are going to twist it, and we are going to crimp it again. And right now, the terminal is properly, right now is ready to apply with the heat gun the temperature and deformate the plastic in order to protect the terminal. This is the procedure to connect properly a terminal in a wire. Don't forget, you need wire cutter for big battery cables, and also you need a lot of tie wraps. This one with a rod end. This is very important in order to fix it easily. And there are other type of terminals in order to support wires. This is excellent because you can pass the tie wrap over there, and after that you crimp it easily. Or this one, plastic, metallic. You need to organize your tools in order to start. Other important tool that I recommend is the screwdriver. Use a screwdriver in order to lose the terminals and tight the terminals on breakers. Use a screwdriver, hand screwdriver. Never use impact tools like this. If you try to use that one, you damage the head of the screw, and you destroy the plastic on the terminal, or you destroyed the breaker, or you destroyed the relay. Never use impact tools. Exactly the same when you tried to tight terminals on the relays. Use appropriate tools. Use appropriate tools. Use the properly wrench, the appropriate wrench. Never try to fix those terminals. Never try to fix those terminals with adjustable wrenches. This is not good. You make chores. You damage the head of the bolt. And never try to use pliers like this to fix it because you destroyed the equipment. This is expensive equipment. Never use those tools. Are not appropriate. The only appropriate are the properly wrenches with the properly size, metric or standard, according with the head of the bolt. All right. Use appropriate tools. Use hand screwdriver. Never use impact tools. This is the most important part. Okay, I am going to get to yours some tips in order to connect the panels. Once again, in a previous episode, I explained the procedure to connect the alternator, the procedure to connect the voltmeter, the ammeter, and I have another chapter, other video, is the video related with the chapter 8, the connection of the dashboard, the gauge, oil temperature, fuel, oil pressure, tachometer, hour meter. I explained in details, step by step, the procedure to connect those gauge with the sensors, oil pressure sensor, fuel sensor, temperature sensors. This is the chapter 8, episode number 1, is the connection of those gauge. Okay, right now I am going to explain basically the connection here on the DC panel and how can you connect the DC panel properly. All right. Remember, previously to this video, you calculate how many breakers you need in your boat, the capacity of those individual breakers in amps per hour. In some DC panels, you have a main breaker. In big panels, you have a main breaker and the individual breakers. In this small panel, I only have the separate breakers. I don't have main breaker. All right. The first step is calculate the gauge of the wire coming in with the power from the battery switch selector. If you remember, in the battery switch selector, you have terminal 1, terminal 2, and the common. From the common, in this particular example, you have two cables. One big cable for cranking, and other small cable in order to bring the power from the batteries into the positive bus bar. This small wire was calculated according with the capacity of this panel. This panel is maximum 25 amps. We use that cable, that wire, for 30 amps. And from the common, we have two cables. One small wire for the panel, and this is the wire going out into the panel and entering here into the positive bus bar on the panel. The negative bus bar of the panel is connected with the main negative bus bar located normally in the engine room or pretty close to the DC panel. Okay, we are going to follow the feeder cable, the cable with the power coming in. That cable is coming, like I explained, from the common of the battery switch selector. And the gauge of this wire is calculated according with the capacity of those breakers, according with the formula that you have on the screen right now, or according with the tables that you have in the ABYC study guide to calculate this wire. Alright, this cable is protected with a fuse. This cable, according with the capacity in amps, is protected with a fuse. And this is the fuse. This is the fuse used to protect the panel. We are going to return into this point. This cable fits the common positive bus bar in one side of the breakers. The other side of the breakers is the output in order to activate equipment. For example, this breaker is for this pump. Ah, yes. When I check, I have power here at the input of the breaker. The breaker in this moment is off. The contacts are open. I don't have power here. When I close the contact, I have power here and the pump starts. For that reason, the test probe is very important. Let me check if the second breaker is working. Oh, that breaker is damaged. You check? Oh, it's working intermittent. Sometimes yes, sometimes no. Okay, I need to replace that breaker. Let me check this breaker. Oh, that's good. Let me check this. Okay, that's the procedure to check if the breakers are working. Oh, I prefer the voltmeter. No, with the voltmeter, it's better with this. Yes or not? All right. This is the cable with the power coming in. The gauge of this wire, the gauge of this cable is according with the capacity of the breakers. All right, right now, I am going to explain the procedure to install the voltmeter and the ammeter. If you remember, in a previous episode, I explained that the voltmeter for a DC panel should be connected. The positive of the voltmeter connected to any part of the positive bus bar, and the negative of the voltmeter connected in any part of any negative bus bar. In this particular case, this negative bus bar, because it's pretty close into the panel. Okay, the negative into the negative bus bar, and the positive here in the positive bus bar. And right now the voltmeter is working. The ammeter. Remember, the ammeter should be inserted in series. The ammeter should be inserted in series, normally in the positive wire. You can connect the ammeter in the negative also, but in the positive is better because this is the amount of amps entering, into the common positive bus bar. I want to connect that ammeter. In this particular case, this ammeter is connected with a shunt. That ammeter is connected with a shunt. I am going to explain right now what is the meaning of that. But before I install this ammeter, I am going to explain the procedure to use the ammeter, to use your multimeter in the function amps. Okay, and this is the procedure. All the multimeters, they have a common connection, one connection for volts and other connection for amps. Okay, because I want to read amps in this panel, I am going to connect my negative on the negative terminal and my positive not in volts. I am going to connect in amps. Alright, I connect in amps, and right now I am ready to select the function amps. You can read amps DC and amps AC. Okay, in this particular case, I am going to read amps DC. Okay, and this is the process. This is the process. I am going to insert my ammeter in series. What is the recommendation? Oh, I have the positive wire. I interrupt the wire and I insert the terminals of my ammeter in series in between those cables separated. Oh, but I don't like that because I need cutted the positive wire all the time. You don't need, because you have breakers. When the breaker is off, the cable is interrupted and you can insert over there the ammeter. I am going to do that right now. For example, I want to know the breaker number 2 is the breaker for the blower. I want to know what is the consumption of this blower when the blower is running. I am going to use my ammeter. Okay, I am going to put my ammeter here, and in this moment the breaker for the fan is off. The fan is not running. What happened when I close the contact on the breakers? The fan starts. Alright. In this moment, the contacts for that wire, the positive wire of the fans, are open in this point. What happened if I connect my ammeter right now in between this point and this point? Of course, the fan starts and I read how many amps is the consumption. 2.4 amps. Once again. This is the real consumption of the fan. I insert my ammeter in series because in this moment the positive cable is interrupted here. Immediately I insert my ammeter, I close the gap, the fan starts, and the ammeter is reading. How much is the consumption of this pump? Remember, be careful. The capacity of the majority of the multimeters is 10 amps. I know that the consumption of this pump is 10 point something. For that reason, I am going to check the consumption of this and I disconnect quickly because it's more than 10. I don't want to damage and I don't want to blow the fuse of this multimeter. Alright, the breaker for this pump is the bottom one, this one. Okay, in this moment the breaker is off. The contacts are open. I am going to close the contact with my hands and I am going to read the amps. 10.2 amps. This is the consumption of this pump. Yes, the only that I need is insert my ammeter where the cable is interrupted. And I know how much is the consumption of that equipment. In this particular example, I don't have a main breaker. When I have a main breaker, I check in that breaker the consumption of all the system. In this particular panel, I don't have main breaker. I have individual breakers. For that reason, I can check with my ammeter the consumption of each individual equipment. That's the procedure to use the ammeter. To use an external ammeter. When I use the ammeter of the panel, normally those ammeters for the small panels are coming with a shunt. The shunt that you have on the screen right now is like a resistor used to protect internally the winding of this ammeter. This is a resistor used to protect the ammeter. If you check, this ammeter have two terminals and both terminals of the ammeter are connected with a green cable, green and green, in order to connect the ammeter. If you check green and green, both terminals are connected here on the ammeter. Alright, let me explain how is connected this ammeter. You remember the positive cable to enter in the positive bus bar? That's the positive cable. The positive cable, the positive cable, okay, here. This is the shunt. And this is the other end. Enter into the fuse and goes into the switch selector. Okay, this is the power coming from the battery, pass through the fuse, and after the fuse, enter in the shunt, and continue, and goes into the positive bus bar of the panel. On the side of the shunt, there are two small connections where I connect both small green cables, and those small green cables enter here into the ammeter, and this is the connection for the ammeter. And right now the ammeter is connected with those green cables and protected, because the big current no pass through the amps, only the small current that is in parallel with this. The shunt is a protector in order to protect the ammeter. There are other ammeters with no shunt. In other words, you bring the big cable here, enter here, and after that continue over there and enter here with no shunt. This is for big DC panels with big ammeters. Those ammeters don't need shunt. In small DC panels, you need to connect the shunt. We are going to refresh the procedure to connect the shunt. Okay, this is the positive cable in order to feed the positive bus bar. That positive cable is coming from the switch selector, the battery switch selector. That's the power from the battery switch selector enter in the fuse. In the output of the fuse, the power enter in the shunt, and the power continue into the positive bus bar. Okay, in the shunt, in one side of the shunt, you have two small terminals where you connect the small wires, those green wires. And those green wires enter here into the terminals of the ammeter. And the ammeter right now is running. I am going to turn the panel and I am going to show to you how the ammeter is running. The voltmeter shows 12 volts, 12 point something. The ammeter, nothing. Let me apply load and you see that the needle goes up. You see that the consumption in amps, DC ammeter, you see, 10 amps, that's the consumption of the fuel pump, you remember? And you remember the other one, the blower, the consumption is 1.2, exactly, excuse me, 2.4. 2.4 plus 10, 14, plus the lights, that's the consumption of the panel right now, around 15 amps. And the voltage is 12 volts. This is the procedure, and look at the lights on the breakers. Yeah, in the output of the breakers, the lights, the LEDs are connected. That's the procedure to connect the DC panel with voltmeter and ammeter.